Hello everyone, in this video I am doing course content number 10 parametric study to infer the response of different structure system, and my topic is deflection analysis of G+2 building by changing and removing position of columns. This is the example of a building I am analyzing for deflection. First of all, open new file, create. So first click on grids, beam grids, edit the plane to XZ. Using snap node beam, draw the nodes and beams of the example we are taking. Now draw the plan of the building by using snap node beam. Now, after drawing the plan, use transitional repeat to draw the full building. Now click on Y plane, and number of steps are 3 and also the spacing is 3. Now draw the plinth level, that is 2 meter. So we are using -2 because we have to draw in the opposite direction of Y. Link steps, okay. Now we have to delete the extra beams. Change the view to front view, select the beams, change the view to 3D view. Now delete the beams. Now the next step is go to properties, choose define, click on rectangle. So the column dimension we are taking is 0.350 meter into 0.350 meter. Add the beam we are taking is 300 into 500. Add, close. Now go to select, choose the beam parallel to Y axis, columns, assign to selected beams, assign. Now for beams, choose the beams parallel to X and Z plane and assign to selected beams, assign, close. So the next step is go to supports, create fixed support, add. Now change the view to the front view, select the nodes, click on support, assign to selected node, assign, change the view to the 3D view. The supports are now assigned as shown. Now go to loadings, click on load case details, choose dead load, add first load, cell weight of beams and columns, add. Second is slab weight, add. Now add third, that is wall load, add and close. Now click on self weight of beams and column, add. Now we are adding self load, that is already given, -1, assign it to the view. Now click on slab weight, add. Click on floor loads. From IS code 875 part 1, see table number 1, unit weight of building material, cement concrete reinforced with 2% steel. This is unit weight. The percentage of reinforcement mostly never exceed by 2% in any member of RCC building. So 2% of reinforcement we can assume to be maximum. So for slab weight, we are assuming self weight of slab is equal to thickness of slab into density. So the thickness of slab we are assuming is 0.125 meter and the density is 25 kilonewton per meter cube. So the self weight of the slab is equal to thickness into density, that is 3.125 kilonewton per meter cube. Instead, we are taking minus 3.125 because it is acting in downward direction. So the range we are choosing is 3 to 6 meter, minimum and maximum. So click on the node cursor, click on the nodes. So here is 0 and 3 and 6. So this is why we are taking minimum 3 and maximum 6. And for sulfate of terrace slab, we are using sulfate of uh, terrace slab is equal to sulfate of slab plus 3. 3, that is waterproofing sulfate, is equal to minus 6.125. We are using minus because it is acting in downward direction. So the range is 9 to 9. Click on the node cursor. 9 9, minimum and maximum range is 9 9, add, close. So this is the floor load. Next is wall load, and we are using IS code 875 part 2 from table 2. Partition wall, brick wall for nominal size thickness 100 mm, 1.91 is given. The sulfate of wall is equals to thickness of wall into effective height of wall into density of brick wall. Assume thickness of wall is equal to 0.15 meter, height of wall is equal to 3 meter, and effective height is equal to 2.5 meter. Density from IS code is 1.91. We have to divide it by 0.1 is equal to 19.1 kilonewton per meter cube, but usually we take 20 kilonewton per meter cube. So the self weight of the wall is equals to 7.5 kilonewton per meter. Click on wall load. Click on member load. We have to apply running load, so that's why we are using uniform force. Use minus 7.5 kilonewton per meter in GY direction. Click on add, close. So for sulfate of parapet wall, we are using 3 kilonewton per meter. Thickness of wall, that is 0.15 into 1, that is height of wall into density, is equals to 3 kilonewton per meter. So add minus 3 sulfate of parapet wall, add, click on close. So click on uniform weight minus 7.5. Change the view to the front view. Click the beams and assign to selected beams. So the other load we are taking on the parapet wall. Change the view, select object, choose the sides walls for parapet loading. Click on assign to selected beams, assign. Click on the view. So the loads are now assigned. Now it's time to add live loads. Click on load case detail, add live load. Click on live, LL, add, close. Click on live load, add. For live load, we are using IS 875 part 2. Go to table number 2. So usually we use different loads for the different rooms, but in this example we are using 3 for all the building. So click on floor loads, add minus 3, and the range is 3 to 9. Click on node cursor, click on nodes, that is 3, and the last top node is 9. So this is minimum and maximum 3 and 9, add, close. Assign the live load. Now next is add combinations. Click on define combinations. Add first combination, that is dead load. Add salvator beams and corner slab it and wall load with factor 1. Add second combination is dead load plus live load with factor 1. Add slab, add all the load cases. Add. Now the third is 1.5 dead load. Change the factor to 1.5 and add slab weight, live load and wall load. Add. Fourth combination is 1.5 dead load plus live load with factor 1.5. Add self weight of beams and columns, slab weight, live load, wall load, dead load. Add. So these are the combinations we are using. Next is go to analysis. Click on analysis command, click on all, add, close. Now click on run analysis, save. So the errors are 0. Go to post processing mode. Okay. Now see the deflections of the columns. Change the scale of the displacement. Change it to 10. Apply. Okay. Now the deflection is visible. Change the beam cursor. And this is the deflection in global axis, and click on local axis. So this is the deflection. We can also see other columns deflection. We can also print it. Click on animation to see the deflection view. Okay, apply. So this is the deflection of the building. So this is the displacements in the table. Node displacements and beam displacements. Click on reactions and click on beam results. Now go to new file, click on create. So in this example, taking this new example, so in this example we are changing and removing the position of the columns differently from the previous example. So draw the building's plan by using snap not beam. By using transitional repeat, complete the whole building. And now assign the properties and loads which we are given in the previous examples. Click on load case detail. These are the loads we are used in the previous example and in this example. Now the next step is analysis. Go to analysis, click on analysis command all, and click on run analysis. Save the structure, click on run analysis, go to post processing, apply. So see the deflection is not visible. Change the scale to the 10. The deflection is still not visible. Change the scale to the 1. Apply. Okay, now the deflection is visible in this building. Now click on reactions. These are the reactions of the supports. Click on beam results, go to displacement, see deflections of the building. So for deflection in beams and columns, click on the beams and see deflection in global axis and local axis. Similarly, we can see for all the beams and columns the deflection in x direction, in y direction, and in z direction. We can also print this deflection of different beams and columns. Only single beam deflection is shown in the report. For example, this is the report of the beam. The deflection in both the buildings is as shown in the figure. And for conclusion, I am taking both the buildings and selecting one beam from the top floor, and this is the deflection in the beam 1 of a building 1, and this is the deflection of building 2 of the beam at the top floor, and the maximum deflection is in the building 2 where we have only used 2 beams in the 10-meter structure. So in this building the deflection is more as compared to the other. The deflection is in global y-axis of the beam. In building 1, the deflection is 0.240 at center, and in building 2, the deflection is 0.591. Thanks for watching.